All right, this video is for the lesson 6.2 homework. We're going to do central angles and inscribed angles. Okay, so real quick. If we've got a circle and here's the center, a central angle would be like 2 radii. Radii, that's plural of radius, right? Radius goes from the center to the edge. So if we have 2 of those, that angle that's formed there is a central angle. Okay? The other thing that's formed is its arc. Okay? So this is its arc in between where those 2 radius hit the edge. The relationship is the measurement of this angle is the same as the arc. Yeah, go ahead and grab it. So like if this angle is 45 degrees, then this arc measurement is also 45 degrees. Okay? Central angle. An inscribed angle, so like if here's the center, an inscribed angle is something like this, right? It's not coming from the center, okay? It can also be, something like this could be an inscribed angle, okay? So we've got an angle measurement here, and then it has, and it's called an intercepted arc. It's just where the 2 legs of the angle hit the circle. So the relationship here is this angle is half of this arc. So if this angle measures 30, then that arc's going to be 60. Okay? Those are the relationships we're using today. That's just the straightforward. It gets a little bit more complicated than that. So first off, naming these things. You need to know how to name them because they don't always give you a picture. They just give you names or locations or places. Okay? So this one says, name the intercepted arc for the given angle. So if the angle is QOP, connect the dots. Q to O to P. That means it's this angle, and then the intercepted arc is where those 2 legs hit. And so that arc would be from Q to P. So we write QP and then we put a little arc over it. So this symbol means angle, this symbol means arc. Okay, geometry is all about using symbols instead of a whole bunch of words, being able to kind of write things in a shorthand. This, like in here, this is the angle measurement. Okay, so it's inside those 2 legs. Okay? All right, for some reason these printed wonky. Where that little box is, that's the X. And you'll see a couple others that look like that too. There should be 2 more. Okay, down here at 7, that little box, that's where the X should be. Right here, that's where the X should be. I don't know why the printer went rogue on me. Okay, so number 3. It says find the value of X. So X is this angle right here, okay, which means here are its legs, and then its intercepted arc is from the end points in between, okay? So central angle is the same as the arc. So if the arc is 120, then that angle is going to be 120. They can get more complicated. So I'm going to give you some hints on the next one. SPQ. So SPQ, S to P to Q. That's this whole measurement in here. Okay? Which means it goes with this arc. Okay? All the way around the circle is how many degrees? 360 is all the way around, okay? So in order to find this entire angle measurement, you need this full arc, okay? This line is just there to mess you up. If I know all of the pieces except from here to here, from U to S, how would I find that distance from U to S? Take the 3 angles, or the 3 arc measurements, sorry. add them up and subtract it from 360, and that's going to give you this arc measurement. These two pieces put together make the full arc. Okay? All right, diameters. Diameters go all the way across the circle, and they also cut the circle in half. Okay? So if all the way around is 360, what's halfway around the circle going to be? How would you find it? By 2. So 180. Okay? So all the way around the circle is 360. Halfway around the circle is 180. That's another relationship that you kind of need to know. So find the value of x. So see, we've got a little expression here. This takes skills from all the way back before Christmas, all the way back before Thanksgiving. Okay? To be able to find this, I would need like the angle measure. You can find the angle measure because of that diameter. That diameter makes a straight line, right? So if I draw just that diameter, that's this piece, C to D, and then I've got this little leg coming off of it, and that's B. If I know this angle is 140, what's this angle going to measure? I think you're right. I think you're mumbling. No, straight line. What's a straight line? Always add up to. Straight line is 180. So remember when we have these straight angles like this, these two angles together add up to 180. So 180 minus 140 is 40 degrees. This angle is 40 degrees. So the central angle is the same as the arc, so I can set 40 equal to 6x minus 8. Yes, you can absolutely menu 3-1 this, okay? I want to work this one by hand, though. 6x minus 8. That was the right? Okay. The reason I want to work it by hand, if you plan on taking Algebra 2 next year, okay, Coach Eckhoff makes you solve equations by hand. Yes, you can menu 3-1 and get the right answer, but if you don't show your work, she counts it wrong. So I'm going to start doing this more often, working these by hand. Okay? If we've got time at the end of the year, we're going to work a lot on solving them by hand just to kind of get your strength up in that. All right, so if I want to solve this equation by hand, what do I do first? You're right. So how do I do that? What do I do first to get the x by itself? Okay, this is the two-step. This is the easy one. When there are two-step equations like this, just a little bit over here, get rid of addition and subtraction first, then get rid of multiplication and division. So do I have an addition or subtraction that I can get rid of? What? Minus 8. So how do I undo a minus 8? Okay. And then minus 8 and plus 8 cancel. And then what's my last step here? Good. So 48 divided by 6 is 8. The 6's cancel. Okay. That's what Coach Eckhoff expects. She wants the steps. So again, just it's not a punishment. It's trying to make sure you have the skills you need to be successful once you're not in here with me. Okay. So all that one wants is 8. Sometimes it asks for the value, sometimes it wants the measurement. All right, hints on 6. 6 is a doozy, okay? Find the measure of WV. Okay, here's why this one is a doozy. You see that little arc in there? See that little arc in that next one? That means those two measure the same. Okay, and your eyeballs go, but they don't look the same. Remember, you can't always trust your eyeballs. You got to go by the symbols. So if this one is 5x plus 10, this one is 5x plus 10. Okay, the other way that you can tell that those two, hang on. No, I don't know if I did that one right. The diameters are key here. TW and SV, right? TW, SV. Okay, those diameters. Let's take the circle out of this one. Let's look at this one without the circle. Let me just draw those two diameters. So there's TW, TW, and then I've got SV. We're looking for like this one up here, right? Which goes with this angle, the central angle. You remember the relationship when we have two lines that cross? What's this angle going to measure? The same as that, right? Well, but that means this angle is going to measure the same as this angle. Okay? So we need that relationship as well. Okay? So that means that this whole piece right here measures the same as these two pieces together. And we're still doing central angles. So if this arc is 12x minus 2, then that angle is 12x minus 2. 12x minus 2. And then we know this is 5x plus 10, and we know this is 5x plus 10. But they're vertical angles, so we know that this equals these two added together. See what I mean? These get dicey really quick. So I can set 12x minus 2 equal to 5x plus 10 plus 5x plus 10. Or I can just multiply it by 2. So what do we get? What does x equal when we do that? Now, let me do this one by hand too. That's a good... Any clue where to start on this one? If I wanted to solve that by hand? I can get rid of the parentheses. That's what I would do. My gut always says get rid of the parentheses. So remember the distribution. 2 times 5x equals 10x. 2 times 10 is 20. Okay, we got an x on both sides. You remember what I told you last year? If you got an x on both sides, what to do? Not add them together, just get them together. Do you remember which one to move? Your brain was going there. Your brain remembered the lesson. Always move the smallest x. Trust me, it just makes life easier. So if I want to move that 10x, how would I move it? What would I do to move it? Subtract it. Anytime you're moving something, you're adding or subtracting. Okay, so 12 minus 10 is 2. Keep the x. Didn't touch the minus 2. That's going to cancel. And then now we're back to a two-stepper, right? So what do I do next? Add 2, okay? And then do what? Divide by 2. So again, they're not, your brains are making them harder. You're so used to fearing them and doing them by hand. They seem overwhelming, but you guys are getting it. You guys know what you're doing. So x equals 11. All right, here's the last part of this one. It has to do with these diameters that they gave us. Right? Remember what I told you? The diameter divides it in half, right? So what is all the way around from S to V? What is that going to measure? It's going to measure 180. I know this piece because I know what X is. I can plug that X in for that X and do 12 times 11 minus 2. And I get 130. So from here, from S to W measures 130. I'm going to let you do the rest to get from here to here. All you need is that little bit. And that's an 8 up there. Sorry. Okay. these can get really complicated. They can have a lot of pieces, and you just kind of have to look for the relationships, okay? All right, that's central angles. Inscribed angles. So remember, the angle is half the measurement of the arc. So if I'm looking for this angle and the arc is 80 degrees, what's the angle going to measure? 40 degrees. Okay, the arc is bigger in this case. Okay, take the arc and divide it by 2. If you know the angle measure, you multiply the angle by 2. Okay, that's the relationship there. All right, number 9. Find the value of x. Here's x right here. Here's its 2 endpoints, right? For that arc. But there's no angle. See how there's no legs that connect straight from those 2? So this is another one with relationships. So I know what this piece is. I have an idea what this piece is.
Pardon this interruption. I need the following students to come.
Okay. So we have arc measurements. We only have one angle measurement, that 110. So if we look at this angle here, that 110, here's the actual angle. Goes from here to here, which means its arc are from those endpoints. Whoop. Okay. So if the angle is 110, what's that arc going to be? 220. Yeah, double it. Okay. So again, to tell the difference, central angles go through the center. The vertex is at the center. Inscribed, this relationship we're talking about now, that vertex is not. See how it's not on the center? Okay. All right. So now I know this part of the circle is 220. This part is 50, and this part is 30x. What's all the way around the circle? 360, right?
So subtract those 2.
You could subtract those 2. Okay, so let's do that. Let's subtract those 2 and see what happens. What is it? 90? Ooh. Try that again. Okay. So that means this piece is the same as 90 degrees. How would I solve for x?
30x equals 90.
If they're the same, mathematically I use an equal sign. How do you solve that one? How do you solve for x in a little equation like that?
You did it right, so
How?
subtract 30.
No! Because 30 is not being added to x. What's it doing to x?
Divide it.
There you go. 30 is being multiplied by x. Okay. All right, last one, another kind of doozy. Oh, FYI, all 3 angles in a triangle add up to what? So you can find this angle measure. Okay. Again, we're starting to get rules that we've done over multiple units. All right, find NLM. Connect the dots. N to L to M. There's no angle measurement there, right? Because there's no angle formed. So we're going to have to do different pieces. That diameter is important. What's the diameter do to a circle? Cuts it in half. So that means this half is 180 and this half is 180. I know the 2 pieces for this half. So that means this piece plus this piece equals 180. So 13x minus 10 plus 7x minus 10 equals 180. The reason I put them in parentheses, if that would be a subtraction sign in between there, it changes the game. With it being addition, it's not going to mess the math up. So we have 13x minus 10 plus 7x minus 10 equals 180. We've got two x's, but they're on the same side. What do I do? Because you can only have one x. Well, you can't, but... So yeah, you can move the smallest, and you just move it on the same side, okay? But we're not necessarily moving it since it's staying on the same side. We're combining. So I can combine 13x and 7x, 13x and 7x, and then I can combine that negative 10 and that negative 10. So 13 plus 7 is 20, keep the x. Negative 10 and negative 10 make a negative 20. And then again, I'm back down to a two-step. I'm not saying that you cannot use menu 3-1 for right now. I'm just going to expose you to this so it's not overwhelming next year. All right. So x equals 10. All right. I'm trying to find that pink. What does this piece measure? 180. Okay, so I know this much is 180. How would I find this other pink piece?
You could plug the 10 in for the x.
Okay, so 13 times 10 minus 10. And that one's going to be 120. Okay. Oh, I read that wrong. I did arc in LM. Look what it says. I need angle in LM. I need this measurement. I need the angle measurement, not the arc. Sorry. Okay, so I need this arc measurement then. So how do I find that arc measurement?
Plug 10 in.
Which would be what, 60? So if this arc is 60, what's that angle going to measure? 30. Okay, you have 3 questions left. I'm going to go ahead and open up the quiz today. That way, if you've got time at the end of class today, you can work on it. And then you've got time tomorrow at the end of class to work on it. Sit, I'm not done yet. Okay, I'm going to try to do this with the quizzes. Okay, the quiz has to be done by end of class tomorrow, though. So if you've got time today to kind of get a little bit done on it, I'm hoping that'll kind of help timing-wise. Okay.